we're going to do a new kind of arithmetic. You've learned arithmetic from kindergarten all the way up till now, but now we're going to do the arithmetic of vector quantities. You've done the arithmetic of scalar quantities. Now we're going to do vector quantities. And what we're going to cover today is addition, subtraction, and multiplication with a scalar. And we're not really going to go through the mathematics of it or the analytical side of it. We're just going to sketch it. We're just going to sketch vector arithmetic. Okay. Well, first of all, let me sketch a vector. This we're going to call vector A. It's an arrow. We represent vectors with arrows. And what's true about an arrow? Well, it has a length. And the length of that arrow represents the magnitude of the vector quantity. A vector quantity has magnitude and direction. I mean, we defined that before. And so, obviously, an arrow has a length and it has a direction. Now, what if I have a vector B over here? Oh, and by the way, if it's quite common to use a capital letter to represent a vector quantity. And when we write down a vector quantity, quite often we'll put a little arrow on top of it, like that. And that little arrow, this little arrow I drew right here, just means, hey, this quantity right here, it's a vector quantity. Well, here's vector B in this example. Now, what do you notice about A and B? Well, they're in the same direction. They're both to the right. And I tried to draw them the same length or the same magnitude. If two vectors have the same magnitude and the same direction, well, then they are equal. We can say that vector A equals vector B. So what this means is that you can just pick up a vector and put it down anywhere you want. And if it has the same magnitude and direction, it's the same vector. So this is A and this is A if I drew it right. So they don't have to be at the same place. You can pick them up and put them down. If they have the same magnitude and the same direction, we say that they are equal to each other. Okay. Now let's add two vectors together. Let's add vectors. Well, let me change B here. Let's let A be kind of the same. But let's let B kind of look like this. Maybe a little shorter, different direction. Okay. How do we add vectors? We're going to add these guys. Use a plus sign. Now we use a different operation for vector addition than we did with scalar addition. And the operation we go through is hook them up, head to tail. Now, this right here, this part right here, we call this the tail of the vector. And this is like an arrowhead. So we call this the, this is the head of the arrow. The pointy end. So, if I want to go A plus B, here's what I'm going to do. I'm going to redraw A. There's A. Now B, I'm going to pick B up in my imagination, I can't really do it with the graphite rubbed on the paper, but in my imagination, I can pick this up and put it down. And there's B. See, I put the tail of B where the head of A is. Now, the result of adding A plus B is, well, you start where A started and you end where B ended. And the result of that, we're going to call that vector R. R for result or resultant. The result of adding vector A plus vector B. What is the result of that? We call that vector R. Okay. And now I could, let's put another vector in there. Let's call this vector C. And let's practice a little bit. Let's do B plus C. Well, I'll just take B, redraw it as best I can, and then add vector C to it. And then I always label the vectors. Here's B, here's C. No problem. I put the tail of C on the head of B, and then here's my result. I didn't draw that very well. Okay, let me zoom in a little bit. Now, what if I went C plus B? No problem. I'm going to start where I started before. I'll redraw vector C. There's vector C. And then I'm going to draw vector B. And notice that I get to the same place. I mean, I could do this over here too. I could go B plus A, and I get to the same result. I have the same resultant vector. So what this tells us is that A plus B equals B plus A, or actually B plus C equals C plus B. In other words, it doesn't matter what order you add the vectors together. I think that's a commutative property, right? You commute the things. And we did the same thing with scalar arithmetic, right? 2 plus 3 equals 3 plus 2. It doesn't really matter. So that's vector addition. Oh, last thing, I can go, A plus B plus C. No problem. So you just draw A. Here, I'm trying to redraw A plus B plus C. And guess what I get? Here's vector R. Starts where A starts, ends where C ends. And there's the result. And I'll leave it to you to figure this out, but what if I go B plus C plus A? I'm going to have the same result. Oh, what did I do that for? Should be an R. You can add these together in any order you want. You're going to get the same answer, same result. Now we're going to do this with numbers and angles and stuff, angles and magnitudes and all that later on. But this is just the basic, just how to sketch them. Always put arrows too on your vectors so that you can tell what direction they're going. Now let's talk about subtraction. Let's subtract vectors. Well, the way we define, so let's say I have A minus B. Well, here's A. I'll draw A again, and here's B. So A minus B. Well, how do we subtract two vectors like this? Well, here's how we define, this is the operational definition of vector subtraction. We basically say this. A minus B is equal to A plus negative B. So we have to make that definition. Now, what is negative B? Yeah, negative B is a vector that is the same magnitude but the opposite direction. So if this is B, this would be negative B. As you know, just sketching it. So now we're just going to add A. We're going to go A plus negative B. So let's sketch it. Here's A, and here's negative B. Head to tail, still head to tail, but negative B. And here's the result of doing A minus B. So this is A minus B. And you can go A minus B plus C. You know, you can put them in any combination you want. But here's one thing. Does A minus B equal B minus A? Is that true? Well, let's see. Let's do B. We already got A minus B. Let's do B. Here's B minus A. Oh, here A would be like this, so I need to go off to the left. Kind of drew it funny. So here's minus B. I'm sorry, minus A. Here's B minus A. Is that the same thing? Is that the same result?
Yes.
Is this resultant vector the same as this resultant vector? Well, they're kind. Oh, I'm sorry. Let me zoom out so you can see both of them. Yeah, is this R the same as this R? No, but we can show that they have the same length, but they have opposite direction. So we can say that A minus B equals negative B minus A. The negative means other direction. We're talking about vectors. Last thing. Multiplying vectors. And I went too long. And if the bell rings, I'm going to finish this lecture, even if the bell rings. So, multiplying vectors and scalars. This is very easy. What if I have 3A? What is 3A? 3 is just a multiplier of A. And 3 is a scalar. It doesn't change the direction of anything. What does this equal? A plus A plus A. So all you have to do is hook up A head to tail with itself 3 times. A plus A plus A. And the result of doing that from here all the way over here, that's 3A. Couldn't be easier. Okay? Now on the worksheet I've given you, you're going to have to combine some of these ideas. Look at this. 2B minus A minus 2C. I think that's the most complicated one. So I want you to just sketch them the way I was just sketching them in the lecture. Also read the book, do these problems and answer these questions and so on. That is all.